Hello everyone, this is Roshni. I'm currently studying in SRIT Anantapur. I'm now in first BTech second sem. So let's dive into my topic. So the topic I got is sources of electrical resistance. So what do you mean by resistance? Resistance is nothing but it is an opposition to the flow of the electrical current in a circuit. Like, see here, electrical resistance is a measure of the opposite to the flow of electrical current in a circuit. It is influenced by various factors, including material properties and physical dimensions. Understanding resistance is essential for designing efficient electrical systems. So, the things are in Ohm's law. Ohm's law states that the current flowing through the conductor between 2 points is directly proportional to the voltage across the 2 points. See, these are resistors and these are voltage. This is an voltage and current is passing through this. So this is called as Ohm's law. Ohm's law is called as V equals to IR, where V is the voltage, I is current, and R is resistance. This fundamental principle helps us understanding how resistance affects circuit behavior and different materials like material properties. So let's see like how these are different materials having varying inherent resistance, which significantly influences resistance. Conductors like copper and aluminum have a low resistance. Insulators like rubber have a high resistance. The resistivity of a material depends on its atomic structure and the presence of impurities. Three resistors are made up of three different materials and have a different cross sections. So this is of a problem like it is a circle, it's a square, and it's a triangle. So it's just an example of how we are calculating the resistance. And temperature effects. Temperature plays a crucial role in determining the resistance of a material. Like for conductors, resistance increases with temperature, like due to increased atomic vibrations. Conversely, some materials like semiconductors may show decreased resistance at higher temperature. Matlab, if you increase temperature, the resistance of conductor like semiconductors is decreased due to some materials because of high temperature, like these are inversely proportional. So that's the reason why if you increase temperature, the resistance of semiconductors will decrease, whereas here these are directly proportional. So if you increase temperatures, the resistance of the conductors is also increases due to atomic vibrations. Like dimensions of a conductors, the physical dimensions of a conductor impact is its resistance significantly. Resistance is directly proportional to the length of the conductor. Like if we increase the length of the conductor, then resistance is also increases. Like longer conductor exhibits higher resistance. See, I've done example, right? So like this. Additionally, resistance is inversely proportional to the cross sectional area. Like if you increase cross sectional area, the resistance will decreases because these are inversely proportional. The reason behind this is the wider conductors allow more current to pass. So resistance is opposition to the flow of current, right? So it decreases. So that's the reason why resistance is inversely proportional to the cross sectional area. Now impurities and alloying. The presence of impurities in a conductor can increase its resistance. Like sometimes the impurities in a conductor can also increase its resistance. Like you can see alloying metals can enhance certain properties but also introduce additional resistance. For example, adding nickel to copper improves its strength, but it also increases its resistivity. So here, length of a conductor affects resistance. We have already seen in the last slide that length is directly proportional to the resistance. And frequency operation. This is a low frequency, this is high frequency. Let's check how it depends on resistance. At higher frequencies, the skin effect causes current to flow mainly on the surface of conductors. The phenomena increases the effective resistance of conductors in AC circuits compared to DC circuits. Understanding frequency effect is vital for designing high frequency applications. Next, geometric effect. The shape and configuration of all conductors can influence its overall resistance. For example, coil wires or twisted pairs can increase resistance due to additional length and complexity. See, if you coil a wire, that increases resistance due to because of additional length and complexity. You are increasing length, right? So that's the reason why it's increasing a resistance. And engineers often consider geometric factors when designing circuits for optimal performances. Now, environmental conditions. Environmental factors such as humidity and pressure can also affect the resistance of materials. Like a moisture can reduce in some cases, while extreme conditions can increase resistance. It is essential to account for these variables in outdoor or industrial applications. Now, conclusion and implications. Like understanding the source of electrical resistance is a crucial for efficient circuit design and energy management. Engineers must consider all factors affecting resistance to optimize performance and minimize energy loss. So they need to check like by using which they're losing energy, and they need to check all the factors that affecting resistance and to minimize energy loss. Ongoing research continues to explore new materials and methods to reduce resistance in electrical system. Thank you for giving me this opportunity.